Okay, so for the first thing I want to do here is I'm going to take the log of both sides. Even though I have this coefficient here, I can deal with that after because I can use my product to some rule or property once I take the log of both sides. So let me try that first. So I have log of 5 times 2 to the 3x plus 1 equals log of pi to the x minus 2. Okay, and these I'm just doing base 10 common log. So now I'm going to make sure I put that in parentheses. And now I can use some log properties. So I'm going to split this apart to be log of 5 plus log of 2 to the 3x plus 1. And then I'm going to bring this down here. So I have x minus 2 log of pi. So my goal here is to get all my x's from being variables to just down on the main line there. So this, I can use a log property if I put parentheses around it, and that can come down in front. So then I'll have log base 5, or not base 5, log of 5 plus parentheses 3x plus 1 times log of 2 equals x minus 2 log pi. So I'm going to distribute that. So I'll have x log pi minus 2 log pi. And I need to do the same thing here, distribute. You can kind of do that as you go once you get used to these, but I'm going to do it in a separate line. Log 5 plus 3x log 2 plus 1 times log 2, so it's just log 2, equals x log pi minus 2 log pi. So now I need to collect my x stuff to one side and just my kind of plain log stuff to the other side. Right, so I'm going to write this as 3x log 2 minus x log pi. I brought this over, equals, I'm going to write it as minus 2 log pi minus log 5, and then also minus that log 2. Okay, so now I'm going to factor out the x here. So I have x 3 log 2 minus log pi equals all this stuff, which is going to end up being over the 3 log 2 base pi. So I have negative 2 log pi minus log 5 minus log 2, all divided by 3 log 2 minus log pi. Now what I want to do is factor out a negative here. So I'm going to factor out a negative. So that will be let's just rewrite that here. So if I could multiply top and bottom by -1, might be a nicer way to look at it. And so that's going to change all my signs. So I'll end up, that'd be a plus, that'll be plus, 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 so everything's positive in there now. And then on the bottom here, I'd have a negative and a plus. Okay. So there's a couple of different formats you might write this as, and that's going to be all equal to x. So let me write that here. So once I divided, this is my final answer. You could also have done it a little bit differently and rearranged it differently and been correct. That would be okay. So just keep that in mind. Another form that I had come up with, you may see sometimes, would be something like this: log of 10 pi squared over log pi over 8. If you kind of start manipulating things and compressing, you could get that. If you fully condensed it. Now let's look at number 6. A drug is eliminated from the body through urine. Suppose that 20% of the drug is eliminated every 3 hours after the drug is administered. So first we need to set what our variables are going to be. So I'm going to have let A equal the amount of drug, and let T equal number of hours since, it was administered. Okay, so our initial function here will be our end amount, A of T. So write an equation giving the amount of drug in the body as a function of the time since the dose was administered. So A of T equals A sub 0 is going to be our start amount, initial. So A0, A0, or A initial. And then I have 20% goes out every 3 hours. So that would be 100% minus 20% would leave me with 0.8. So you got to kind of think back to how we set these up at the beginning. And then if it's happening every 3 hours, I'm going to be dividing my time by 3 for the exponent. So that's my answer for part A, my function. Now estimate the half-life of the drug. So that means my end amount would be a half of the initial amount. So half A sub 0. And then I have A sub 0 times 0.8 T over 3. Now, one thing you can do, you don't really need to have that there. You could just kind of assume your start is 1, or, whatever it is, your end is a half of that. So you don't need to write that in there that way. Usually we don't. Or you could just pick, half of one, or if you want to pick 2 here and 1 here, anything that's a half. So now we're going to take the log of both sides to solve that. So that leaves me with log of half equals T over 3 times log 0.8. And then I want to divide both sides by log of 0.8. But I'm also multiplying by 3, okay, because this is really like T log 0.8 over 3, so I can multiply by the reciprocal, which would be 3 over log 0.8 on both sides. So we are going to write this as T, so that leaves us with T equals 3 log half over log 0.8. And then you could crunch the numbers and calculate that out, and you will get approximately 9.32 hours is the half-life. Okay, so now you have a new equation. You could write it as a half-life equation. So this is T is about. Okay. Actually, I already have that here. So T. So you could write the half-life equation if you wanted to write it like this. We have a new format we could use, and it would be A of T equals A of 0 with a base of a half to T over 9.32. So if we raise that up to T over 9.32, that gives us that equation. So now we have part C. If the initial dose is 10 milligrams, how much will remain in the body after 24 hours? So we have our A of T equals A initial is 10 in this case, 0.8 to the T over 3. So we are given 24 as T. 10 times 0.8 to the 24 over 3, which is 8, right? So now just calculate this out on your calculator for word problems. That's totally fine. So 0.8 raised to the 8 power times 10, we are going to get 1.68. So it's about 1.68. So our answer would be there is about 1.68 milligrams. Make sure you use units. Left after 24 hours of administration of medicine. Or drug, I should say. Okay, so that's it for that answer. Make sure you use sentences and units and all that good stuff. So here we have, we're coming on the last couple problems here. So, or last one. Yeah, awesome. So last one is number 7, a home purchased 4 years ago for $240,000 was sold for $290,000. If its value continues to increase exponentially at the same rate, when would the house be worth $500,000? Okay, so this could be done a couple of different ways. We could figure out, take the difference, divide by the original, and get that there's a 0.2083 would be your increase, or about a 21% increase. Or you could set it up this way, just do 240,000 x equals 290,000, and divide both sides by 240,000, solve for x, which would be my percentage, would be 1.2083. So that's including my 100%, not just the part of increase. So my base is going to be this whole thing. This is my base. And I have my current value, or my A initial, sometimes it's called P, and I have my end amount, just like before. My A of T is going to equal my A initial, or sometimes it's called P initial. I'm not sure in this textbook, versus the, P at the end for principal. But then we have our base is 1.2083 to the T over 4, because it was 4 years ago. So I'm looking at this base happening every 4 years. Okay, so now I'm going to plug in my values, and I want the 500,000 is what I want my end worth to be. My initial amount was or my A value now. My value now is 290. So that's actually not A initial, just A at the time. Okay. So I have 290,000. My base is 1.2083. Call this like current, okay? And then raised to the T over 4. So I'm looking for how long this will take. So I need to solve for my exponent. So I'm going to need to use logs. So my first step would be divide both sides by the 290,000. Get rid of a lot of these zeros here. So I have 59 over 29. So I'm going to try to leave that as a fraction as long as I can. So 50 over 29 equals 1.2083. I want to avoid rounding if I can, or until I get to the end. So then I have that raised to the T over 4. So now I'm going to take the log of both sides. This will come down in front, so I have log 50 over 29 equals T over 4 log 1.2083. Okay, so almost there. I just need to multiply both sides by the reciprocal of this. Okay, so I'm going to multiply by 4 over log 1.2083 on both sides. So then I'm going to have T equals 4 log 50 over 29 over log 1.2083, and then calculate that out. Just use your calculator and crunch the numbers, but try not to round. Just type it in, go 50 divided by 29. You'll get some decimals there, and then leave that there and go log of answer times 4, and then hit equals and divide by log 1.2083. Don't forget to hit equals or use parentheses. So that comes out to be about 11.51. So we will say it will be worth $500,000 in approximately 11.51 years from now. You could say 11 and a half, or you could round up, or 12 years to make sure, be safe, right? If you're doing to the nearest year. So you have to kind of think about that. Okay. So I hope that helps. You'll see some more word problems in the homework, so you may have some questions about that and want me to do some more videos toward the end of the week. I just wanted to get these out and get you going on it so that you have plenty of time to absorb all that. So have a great day, and again, let me know if you need anything.